Today's lesson will show you how to communicate enthalpy changes. Enthalpy notation can include a lot of different letters. The delta H indicates that there is an enthalpy change. The degree symbol tells us that the enthalpy is measured in standard state. The subscript between the delta and H indicates the reaction type. The subscript M indicates that it is the molar enthalpy. Right underneath the enthalpy notation, the chemical symbol for the substance is written. There are 4 different ways to communicate enthalpy changes. For today's lesson, you will be learning about the first 2. The first way to communicate enthalpy is by stating the molar enthalpy of a specific reactant in a reaction. If the enthalpy change is measured at standard SATP conditions, we indicate this with the superscript degree type symbol. The standard values are what are shown in your data booklet on pages 4 and 5. When common reactions are shown, no chemical equation is necessary. For equations that are not obvious, it is a good idea to include the chemical equation. The signs, negative or positive, of the enthalpy change indicate if the reaction is exothermic or endothermic. If one reaction is endothermic, the reverse reaction would be exothermic. For this example, the standard molar enthalpy of combustion of methanol is shown. When 1 mole of methanol is combusted, there are 725.9 kilojoules of energy released. The negative sign tells us that the reaction is exothermic. The notation for the enthalpy change includes a small c because it is a combustion reaction, a small m because it is molar enthalpy change, and a degree type symbol because the measurement was taken at standard state. The next way to communicate enthalpy changes is by stating the enthalpy change beside a balanced equation. While molar enthalpy is specific to a certain chemical in the reaction, this form of communication is for the overall reaction as shown. For this reason, the value may need to be adjusted. To do this, we multiply the chemical amount from the coefficient in the equation by the molar enthalpy of reaction. In the example shown, the standard molar enthalpy of combustion of sulfur dioxide must be multiplied by 2 because the coefficient in front of sulfur dioxide is a 2. Once the multiplication is done, the energy amount is for the reaction as shown. 2 moles of sulfur dioxide reacting with 1 mole of oxygen will result in 197.8 kilojoules of energy being released. Because the enthalpy change placed beside the equation depends on the equation as shown, the energy amount will change if the equation is changed. This rule will be used later on in this unit when we learn about Hess's law. If you want to switch the reaction enthalpy change back to the molar enthalpy, divide the energy amount by the coefficient in front of the chemical that you want to determine the molar enthalpy for. In this example, the standard molar enthalpy of combustion of hydrogen sulfide is given. This value will need to be multiplied by the coefficient in front of hydrogen sulfide in the balanced equation. This is the end of our lesson on communicating enthalpy changes.